All right, 3.1 quadratic functions. For your quadratic function or quadratic equation, it will produce a parabola. It can do one of two things. It can open upward or open down. Talking about opening up means concave up. Opening down would be concave down. So talking about a concavity. If it opens up, then you have a vertex at the bottom, which would be your minimum, your lowest value. If it opens downward, then you would have a max at your vertex. Notice the vertex coordinates, HK. And also remember, the last time we saw HK was the coordinates of the center of a circle. So, but HK is also the coordinates of the vertex of your parabola. All right, so the standard form of a quadratic equation, f of x is equal to a times x minus h squared plus k. And notice a is not equal to 0, because if a was equal to 0, then of course all of this would be, removed. So a cannot be equal to 0. So if a is greater than 0, or in other words, if a is positive, that means your parabola will open upward. That would be concave up. If a is negative, or a is less than 0, then it will concave down. All right. Oh, also notice the coordinates of your h and k. We'll come back to it when we actually have to use it. You'll use the opposite sign for h, and you would use the actual sign for k. And so when we go to pull our vertex from the standard form, we'll reemphasize that. But notice there's a minus sign in the formula. So we wouldn't use negative h here. We would use h. So use the opposite sign for h, and then use the actual sign for k. All right, now scroll up. All right, so graphing quadratic functions with the equation in standard form. Give you about 5 steps in order to get a rough sketch of your parabola. First thing you want to do is determine concavity. So in other words, what we're saying here is A positive or negative. That will determine whether you have it concave up or concave down. Determine your vertex. Find X-intercepts, if any. Find your Y-intercept. Then you want to plot the points, and then any additional points as necessary. So don't forget, whenever you're trying to graph anything, the more points you have, the more accurate your graph will be. So after you plot points from steps 2 through 4, if you need some more points, then just plug in some values for x, find the corresponding y value. And the more points you have, once again, the more accurate your graph would be. All right. So I want to go ahead and try this out. F of x is equal to negative 2 times x minus 3 squared plus 8. First step is to establish concavity or determine concavity. A is equal to negative 2, so that means our parabola opens down. Because A is negative, our parabola will open down. All right. Then our vertex is 3 and 8. So once again, you use the opposite sign of your 3 and you use the sign of 8. So the opposite sign of H and you use the actual sign of K while it's in the standard form. So it gives us 3, 8. Next, we find our x-intercepts. Remember, to find your x-intercepts, you start off by letting y be equal to 0. And also don't forget f of x and y are synonymous. So we're talking about f of x be equal to 0. That's what I did right here. Let 0 be equal to f of x. Or let f of x be equal to 0. Subtract h from both sides. Divide by -2. Of course, don't let me scroll up too fast if I'm about to go past something that you're trying to write. So once you divide by -2, you have -4, not -4, excuse me, 4 equal to x minus 3 squared. And you would take the square root of both sides. Don't forget for the square root property, on the side that the square root does not cancel, you have plus or minus. Same thing. The vertex would be 3, 8. So, yeah, be 3, 8. Yeah. All right, so right here, we're going to add 3 to both sides. That gives us x plus, what, x equal to 3 plus or minus 2. And since you can add and subtract 3 and 2, you would go ahead and do so. 3 plus 2 is 5. 3 minus 2 is 1. And that will give us our 2 ordered pairs, 5, 0, 1, 0. So don't forget y was 0. So that's why you have 5, 0, and then 1, 0. Any problems? All right. Y-intercept, you let x be equal to 0. So you just plug in 0 into the function for x. So it's -2 times 0 minus 3 squared plus 8. -3 squared is 9. -2 times 9 is -18 plus 8, which is -10. There we go. So that order pair will be 0, -10. Remember, we started off by letting x be equal to 0. So it's 0, -10. All right, questions? Any questions?
Professor,
Mm-hmm.
I don't have a question, but I know where I would have made a mistake at.
Mm-hmm.
I would have foiled that x minus 3.
Um, well, you wouldn't have, you just would have made more work for yourself. You still would have got the right answer because remember, ultimately, you would have been substituting in 0 for x. if you're talking about it at this step. And so you would have folded out, and that's fine. You would have just had an expansion. But then when you plug 0 in for x, you still would have came down to -10.
Just sharing my mistake I would have made.
Yeah. So go ahead and grab those 4 points. And like I said before, if you want to be more accurate, then you would plug in more values for x to get the y values and plot those points. But those 4 can give you a rough sketch as to how the parabola will be set up for you. All right. Questions? Any questions before we do another one? All right. Finding the vertex of a parabola in our regular general form of our quadratic equation, ax squared plus bx plus c. So we can find h by doing -b over 2a, and then take -b over 2a and plug it into the function, and that'll give us k. All right, so let's look at this one right here. F of x is equal to -x squared minus 2x plus 1. So we see that first we look at a. A is -1, so that means it opens down. Negative values for a means it opens down. Positive value means it opens up. Now we can take a, which is -1, and b, which is -2, and plug it into the formula to figure out what h is. Don't forget that there's a negative in the formula, and we plug it in -2. So that's going to be -2. So make sure you don't lose a negative when you do your substitution. Then on bottom, 2 times -1. That'll be 2 over -2, which is -1. All right. Then we take -1, plug it into f. And that gives us 2. So our vertex is -1, 2. All right, so step 3, want to find our x-intercept, we need to let y be equal to 0. So it's x minus 2 minus 2x plus 1 equal to 0. Once again, just substituting in 0 for f of x. But I cannot factor this or solve it and get a integer out, so I need to go ahead and use my quadratic formula. A is equal to -1, B is equal to -2, and C is equal to +1. And we plug it into this formula right here accordingly. All right, so doing that work simplifies to 2 plus or minus square root of 8 over negative 2 after we do our substitution and simplifying accordingly. Now we're trying to graph this, so we need numerical values. So I went ahead and converted them both to decimals. So it's negative 2.40 and then 0.40 as my two ordered pairs for my X-intercepts. All right, questions? Any questions? All right. Now we find our y-intercept by letting x be equal to 0. So let's say something. Let's see the beginning of step 3. Step.
Professor, how did you get that 2.4?
Calculator.
You do the square root of 8 first, then add the 2?
Depending on the type of calculator that you have, but yep, you can do it that way. Square root of 8, add 2, then divide by negative 2.
All right, thanks.
Yep. Now, if you have the type of calculator, you can do it like this. You know, as long as you use those parentheses, that will cover it as well. All right. So are we good to go? No, somebody asked for the beginning of step 3. Okay, good, not a problem. So y-intercept, just like for the x-intercept, we let y be equal to 0. For the y-intercept, we let x be equal to 0. And so we plug in 0 into our function. So 0 squared minus 2 times 0 plus 1 ultimately would give us 0, 1 as the ordered pair. All right, and then graph those points.
I have a question.
Yep.
Are we always going to be getting one answer for y, or is it just because there's no like square root that we have to do it?
Yeah, for your y-intercept, there should only be one y-intercept.
Okay.
Good question. Also, when it comes to your x-intercepts, it's possible that you may not have an x-intercept because if you have a parabola that does this, notice it's not intercepting your x-axis down here. So those would be imaginary, so you just wouldn't have any x-intercepts. So that's why in that 5th step, it says, you know, you would just pick out some points to plug in, you know, so. But yeah, but you only should get one y-intercept. All right. Any questions? Any questions? Oh, forgot I had this down here. All right, so we do this before we go to that. Very good. All right. All right, so if A is greater than 0, in other words, A is positive, then F has a minimum. We already talked about that, but just re-emphasizing it. F has a minimum, and that's at negative B over 2A. Remember, that's your H. And then if A is negative, then F has a maximum at that point. You know, we're just talking about your vertex. Remember, it's positive, A is positive. It opens upward, so it will have a minimum at the vertex. If A is negative, it opens downward, so it will have a maximum at your vertex. So this next one says consider f of x is negative 3x squared plus 6x minus 13.
Could you scroll up for a second? Just 1 second, please.
Is right there? Or?
That's good. Yep. I'm good, Professor Tucker. Thank you.
All right, not a problem. So we have this function right here, 3x squared, negative 3x squared, plus 6x minus 13, determine whether it has a minimum or a maximum value. And so we just finished talking about that up here. If A is negative, then it opens down, so that means it has a maximum. All right, scrolling up. Anybody still holding on to this statement? All right. So then it says find the minimum or maximum. So in other words, find the vertex. Remember, A is negative 3, B is 6. So to find H, the first component, the X component of our vertex, you plug in 6 for B, then negative 3 for A. So that's negative 6 over 2 times negative 3. So it's negative 6 over negative 6, which is positive 1. Then to find our Y component of our vertex, K, plug 1 into the function. And hopefully I'm not going up too high. Let's do it like this.
Could you scroll down a little bit to A? Yeah.
See, is that too small? Anybody? Okay. All right, so then that's all of A and B. And so that'll give us our vertex at 1, negative 10. All right, any questions before we scroll up? All right, let me erase some of C so we can walk through it before you guys add all of it down. Let me see how I want to erase this. All right, so don't look at this right now. That has nothing to do with it. I wrote it kind of too close. I need to figure out how to move it. But identify the domain and range. So basically, we have our parabola. Our vertex is 1, -10. It opens downward. They want us to identify the domain and range. So your domain, don't forget, are your x values. Talking about moving from left to right. Your range are your y values. You're talking about up and down. So when I look at my domain and I look at my parabola, it will continue to get wider and wider from infinity to infinity. Infinitely get wider and wider. There's nothing stopping it from getting wider and wider. Remember, your domain is left to right. Are there any values or any restrictions on the values you can plug in? And the answer is no. So your actual domain will be just negative infinity to positive infinity. All right. And that will always be the case for your parabolas. Your infinity, it will be from negative infinity to positive infinity. All right. So now your range is up and down. And that's going to go from negative infinity up to that -10. Remember that -10 comes from the y component of your vertex. And notice I also used a bracket on that 10. All right, questions on the domain and range?
I have a question.
Mm-hmm.
Why is it plotted that way if it's -10? Like, wouldn't it be
Yeah,
like
the
positive?
graph.
The graph.
Hold on. So you say why is it plotted that way?
Yeah,
Yeah,
like,
it's at
Oh,
1 and a positive 10.
oh, that was just a rough sketch. I was just,
oh, okay.
yeah, that wasn't accurate at all. I was just, the main thing was the fact that it was the vertex and it was open downward. Yeah, I wasn't trying to do that to accuracy. Yeah,
All
Okay.
right.
yeah, you're absolutely correct. Because you can use -10. Someone asked, why could you use bracket? Why are you using bracket? Because -10 is a part of your range. -10 is a part of your range. Yep. So, and you never use brackets on your infinity signs because you can never include infinity. And so now this over here in the green, I was just saying that if your parabola opened upward, then this is how your range would be written. So the green is just a whole nother problem basically. So I was saying if your parabola opened upward with that same vertex, then your range will go from -10, excuse me, up to positive infinity, because that's the lowest value. That -10 is the lowest value. Here, the -10 is the highest value. So that's why it goes from negative infinity up to -10. All right. Questions on anything? All right, so we're good. All right, so that's it for 3.1. Just 109. We got a little time. I'm gonna pause right here though. Went to the dentist this morning, so was trying to talk least amount as possible, but I wanted to go ahead and get at least one section in. So I'm going to pause right here and we'll pick back up on next class where we left off. Any questions, comments, concerns before we close out today? Make sure we're good.
I knew you sound funny. You sound like you was sluggish.
Yeah, I'm a little sluggish, man. I am.
I was like, you had too much of a spring break.
Yeah. So I'm gonna go ahead and close out, like I said, for today, but I still want to go ahead and get one section in. So you guys have a good one. Y'all be safe, and I will see y'all on Wednesday.
All right, Professor Tucker, you have a good day.
All right, you do the same, sir.
Thank you. You too.
Thanks, you do the same.
Hey, can I have you for 2 seconds real quick,
Yep.
Professor?
Yep. Let me stop the record though.